Welcome to ClickMyProject.com. Our project title is Channel Acquisition for the High Frequency Skywave Massive MIMO OFDM Communications. This is our abstract. In this study, we will look at orthogonal frequency division multiplexing, modulated high frequency skywave massive multiple input and multiple output communication. In this space frequency time domain, the first present the idea of the triple beams, and then we develop a triple beam based channel model utilizing sampled triple steering vectors. We then research the ideal channel estimate and pilot design for the pilot segments using the exciting channel model. We specially identify the circumstances that permit pilot reuse across the numerous user terminals and which sharply lowers the pilot overhead and raises the number of UTs that may be applied. This is our block diagram. In this we use the MIMO. MIMO means multi-input and multi-output. So we use the stream from stream 1 to stream n. This is the n number of input. And use the baseband processor. This processor separate the baseband from the signals. And then RF chain means it's a radio frequency. It separate the frequencies of the signal by using the band from first chain to k chain. And then this is analog processor. Analog processor we done it for the analog segmentation. Here we use the some antennas using for the analog processor. And then in the receiver part, analog combiner. Combiner is the combination of the analog as well as the received signal. And then in the receiver part also we have the RF chain 1 to RF chain KR, that is from 1 to n. And then finally we move on to the baseband combiner. And then we have our output is multi-output. So we get the multi-output. MIMO concept with the OFDM is explained in this block diagram. This is our Matlab platform for run our code. This is our program files, and by go to the main file, click the right click and execute it, run and execute it. This is a data segmentation as the 16th one. After execute our main program, we got the four graphs related to the SNR and root mean square error. That is, the first one is the SNR is the signal noise ratio. Signal noise ratio with the root mean square value, that is for the four condition. The first condition is the linear interpolation, and then second is the spine, third is the discrete Fourier transform in linear interpolation, and the discrete Fourier transform in the cubic interpolation. This is the first one. And then this is the second one is this also the difference, the combination between the SNR and the mean square error. The first one is the MMSE, and then second one is the DFT based. First one is the normal, second one is the DFT based. DFT is the discrete Fourier transform. And then this is a third diagram. This is also the relationship between the SNR and the MSC. With the first one is the linear interpolation, and then the spine cubic interpolation, and the MMSE. And then this is the fourth one. This is also between the SNR and MSC. These are the linear interpolation, cubic, DFT and DFT. These are the four graphs we got our MIMO process.